Okay, let's try some more problems. So let me scroll down. So this one, we need the domain again. And so we're dealing with the x values, or the independent variables. And I'll use both types of notation here. So it looks like we start at a lowest value of -7, and it goes to a highest value of 7. So this one, even though it's a different curve, actually has the exact same domain. So we can say that x is bigger than or equal to -7, but it's also less than or equal to +7. And using the interval notation, it just looks like -7 to 7, both closed with brackets because we include those endpoints. Now, just to kind of change it up, we can also ask what the range is. And remember, the range deals with the y values, or the dependent variables. But it works the same way. We're always going to start with the lowest value. So the lowest possible y value looks to be -3 at both of these points. And we go to the highest possible y value, it looks to be at +4. So we can use our interval notation going from -3, including that point, because it is filled in there, and going all the way to +4, again, including that point. Or using the inequality notation, we'll say that y is bigger than or equal to -3 or less than or equal to 4. And let's keep going with these. Now, this problem, again, is asking for the range, but it's a slightly different problem because now we don't have this kind of continuous curve. Like if we go up and look at this problem, for our domain, it was every x value between -7 and 7. Because any possible x value, you can find a y value. Like even for something like -5.4, there is a y value associated with that, and so therefore it's in the domain. Or a value like 1.2. If you go up to the curve, there is some y value associated with that specific x value. So for this one, because it's a continuous curve, it includes all x values within kind of this set here from -7 to +7. But for this problem here, notice that we just have a collection of points. So for instance, when x is -4, the function doesn't exist there. So -4 would not be in our domain. Same thing with -3 or -3.5. But a value like -2 is in our domain. Value like 0 is in our domain, and so on. So our domain is just a set of points. It's the points -7. Let me just write these out. -5, -2, 0, and 5. And our range, likewise, is just the corresponding y values, starting from the lowest to the highest. And so it looks like at -3, -2, so let me write these out. And we have at 2, and then at 4. And even though I've just written this out as a list, sometimes you'll see it written in what we call set notation. So I can use kind of these fancier brackets to mean the set of these points, -3, -2, 2, and 4. This is the set of all values that are actually in the range. So you can either write it out as a list, or you can use this nice set notation. And you wouldn't use inequalities here, because if I wrote that x is bigger than or equal to -7, but less than or equal to 5, this assumes that values like -6, -4, -3.8 are all in the domain, which they're not, because we don't have points graphed at those different x values. So this interval notation just doesn't work when it's a set of points rather than a continuous curve. And again, you wouldn't want to use the interval notation either. So this is the inequality notation, but the interval notation -7 to 5 also would not apply, because this notation implies that all values between -7 and 5 would work. These are essentially equivalent, so if one doesn't work, the other doesn't work as well. Now moving on, we can look at one final range question. And we know that the range deals with the y values, or the dependent variables. And since this is a continuous curve, it's not going to be a list of points. It's going to be a range of values, starting at the lowest, which looks to be -9. And then we go to the highest point on the graph, which is at -2. So y is bigger than or equal to minus 9, but it's less than or equal to minus 2. And using the interval notation, it goes from minus 9 to negative 2. But in both of these cases, it includes the endpoints because those endpoints are actually a part of the graph. If there was a hole there, then it wouldn't be included. A hole is generally graphed with like an open circle. But since we didn't see anything like that, we can assume that those lowest and highest values are actually a part of the graph. And let's do one more just to wrap this up. We're again back to the points, and we're dealing with the domain. So since domain deals with the x values, we're just looking at which x values would actually have points part of our function. So it looks to be minus 7, minus 3, minus 1, but also at 1 and 4. So there's only 5 different x values that are actually graphed, which is why we didn't use our interval or inequality notation to describe the domain here, because it literally is just these 5 points that can actually be graphed. Any other x values like minus 2 or minus 5.6, those simply don't have a point on the graph, so they wouldn't be included in the domain.